I'm David Falk from the Leiden University Medical Center. I work there as an assistant professor and principal investigator. Today I will introduce our latest steps in using affinity chromatography mass spectrometry to characterize the impact of glycosylation on the interaction between antibodies and their immune receptors. Antibodies, also called immunoglobulins, enable the adaptive recognition of pathogens. Through the interaction with Fc receptors, this is translated into immune responses. The essential binding event between immunoglobulin G and Fc gamma receptors is strongly regulated by glycosylation on both antibody and receptor. This includes direct carbohydrate-protein and carbohydrate-carbohydrate reactions. Our affinity chromatography mass spectrometry setup consists of the immobilized receptor as a stationary phase, on which a mixture of antibody glycoforms can be separated with a pH gradient. This correlates to the binding strengths of individual glycoforms. Structural information is obtained with online native electrospray mass spectrometry. The ability to detect the binding strengths of individual antibody proteoforms in a mixture is unique to our system. Other techniques need to employ laborious glycoengineering to achieve similar feats. We had done this previously for classical monoclonal antibodies and gotten great results and new insights, for example on pairing of glycoforms in the heavy chain dimer. However, IgG can carry additional complexity on the antigen-binding fragment, such as additional glycosylation. This cannot be resolved by intact mass analysis, as it results in a large number of possible variants with similar or even identical mass. We utilize a so-called Middleup approach, where IgG-specific bacterial proteases cleave the antibody in the hinge region, separating the heterogeneity of Fc and Fab domain. It was far from trivial to find the correct enzyme. Several amino acids in the hinge region are essential to receptor binding and Fc stability. Finally, we were able to use this approach and characterize the Fab fragment in the flow-through, as well as the structure and Fc receptor binding of the Fc fragment. Binding data for the classical map was identical to the intact protein approach. However, the increased resolution in the mass spectrometry domain, but especially in the separation, allowed for an even higher affinity resolution. Also, for the Fab glycosylated antibody, we observed the well-known affinity difference of single monosaccharide additions, representing a mere per mil of the molecular weight of the antibody. A highlight was the partial separation of regioisomers of a single galactose residue.